Hi guys, Professor Dr.Taj Rahman here. Welcome you all back to my YouTube channel Rahman Chemistry Coaching Academy. Today we are going to discuss and explain the third example of conformational isomerism, that is butane. This is butane molecule with molecular formula C4H10, and these are the structure formulas of this butane molecule. The numbering to carbon atoms in this butane molecule can be carried out from both right and left side, that is 1 2 3 4 or 1 2 3 and 4. These are the Sahar structures and these are the Newman projections of the butane molecule. In these Newman projections of butane molecule, the front carbon, that is carbon number 2, is represented by a dot, while the rear carbon, that is carbon number 3, is represented by a circle. These two are the eclipse and stagger conformers of butane molecule. In these Newman projections of butane molecule, the butane molecule is viewed from the front carbon, that is carbon number 2, this one. These are the ball and stick models of the partially eclipsed and fully eclipsed conformers of butane molecule, and these two are the ball and stick models of the gauge staggered or skew conformers of butane molecule. These energy values indicate the energy to barrier of rotations between these groups present on the front and rear carbons of these conformers of butane molecule. Now look at to this diagram. This diagram shows six different conformers of butane molecule, that is 1 2 3 4 5 and 6. These six conformers of butane have been obtained by rotation of carbon hydrogen bond on the rear carbon with respect to carbon hydrogen bond on the front carbon. Among these six conformers of butane, this one with dihedral angle of 0 degree, this one with dihedral angle of 120 degree, and this one with dihedral angle of 240 degree are called eclipse conformers, while this one with dihedral angle of 60 degree, this one with dihedral angle of 180 degree, and this one with dihedral angle of 300 degree are called staggered conformers of butane. Among the eclipse conformers of butane, that is this one, and this one, the first one, that is this one with dihedral angle of 0 degree, is called fully eclipsed conformer of butane. The reason is that in this conformer, one methyl and two hydrogen eclipsing can be observed on both front and rear carbon. That is why this is called fully eclipsed conformer of butane. Due to this, steric strain or van der Waals repulsion is high, and thus this is the highly unstable conformer of butane. These two eclipse conformers of butane are called partially eclipsed conformers of butane. The reason is that in these two conformers, two methyl hydrogen and one hydrogen and eclipsing can be observed on both front and rear carbon atom. As the sizes of hydrogen atoms are small to fully eclipse the sizes of the methyl groups in these two conformers, that's why they both are called partially eclipsed conformers of butane. The steric strain or van der Waals repulsion in these two conformers is also low, due to which they are more stable as compared to the fully eclipsed conformer of butane. Now look at to the remaining three staggered conformers of butane, that is this one, and this one. Among these three staggered conformers of butane, this one with dihedral angle of 180 degree is called anti-staggered conformer of butane. This is called anti-conformer of butane. The reason is that the two methyl group on both front and rear carbon are anti or opposite to each other. In this conformer, the two bulky group, that is methyl group and hydrogen atoms, are on both front and rear carbons are part apart from each other, due to which steric strain or van der Waals repulsion is low, and thus this conformer is highly stable conformer of butane as compared to these two staggered conformers of butane. Now these two staggered conformers of butanes are called Gauge staggered or skew conformers. In these two conformers, the two methyl group on both front and rear carbons are close to each other, due to which steric strain exists, and thus they both are unstable conformer as compared to this anti-staggered conformer of butane. Now again, look at to these six conformers of butane. We can notice that these two eclipse conformers of butane with dihedral angle of 120 degree and 240 degree are mirror images of each other, and hence they are enantiomeric and equi-energetic. While these two staggered conformers of butane, that is this one with dihedral angle of 60 degree and this one with dihedral angle of 300 degree, are again mirror images of each other. They are also enantiomeric and hence equi-energetic. Thus, this means that while studying conformational analysis of butane, we have a total of 4 conformers instead of 6 conformers, that is fully eclipsed, partially eclipsed, Gauge staggered or skew, and anti-staggered. This graph shows the potential energy versus bond rotation for these 6 conformers of butane molecule. This graph shows two energy maxima and two energy minima for the eclipsed and staggered conformers of butane molecule. Now look at to these 6 conformers of butane molecule. From the look of this diagram, we can say that the fully eclipsed conformer with zero dihedral angle is highly unstable with 20 to 25 kilojoule per mole energy barrier. These two partially eclipsed conformers with 120 and 240 degree dihedral angles are the second one unstable conformers with 14 to 15.1 kilojoule per mole of energy barrier. These two conformers, that is Gauge staggered or skew conformers, are the third one unstable conformers with 3.7 to 4.1 kilojoule per mole energy barrier if the butane molecule is in gas phase, and 2.3 to 2.4 kilojoule per mole energy barrier if the butane molecule is in liquid phase. Now onward from 180 degree to 360 degree, if the rotation of one part of the butane molecule with respect to the other part around the middle carbon, that is carbon number 2 and 3, is continue, we can observe that the repetition of these conformers can be observed. That is partially eclipsed conformer at 240 degree, Gauge staggered or skew conformer at 300 degree, and fully eclipsed conformer at 360 degree can be observed. Now the order of stability based on the energy difference in kilojoule per moles per these conformers of butane can be write as the fully eclipsed conformer is highly unstable with 20 to 25 kilojoule per mole energy barrier. The partially eclipsed conformers are the second one unstable conformers with 14 to 15.1 kilojoule per mole energy barrier. The gauge staggered or skew conformers are the third one unstable conformers with 3.7 to 4.1 kilojoule per mole energy barrier if the butane is in gas phase, and 2.3 to 2.4 kilojoule per mole energy barrier if the butane molecule is in liquid phase. Now again, if we look at to this graph, various terms are used in this graph, that is syn-periplanar, anti-periplanar, synclinal, anticlinal. So these terms I will discuss and explain in my next video lecture. So this was all about conformational analysis of butane. If you find my video interesting and informative, then please like, share and subscribe my channel for more videos.